Hello, everyone. Welcome to today's masterclass, Generative AI Opportunities in Smart Cities by Hossam El Shoukry. Thank you for joining us. In this exclusive section, we will explore how generative AI is transforming the future of smart cities, reshaping infrastructure, optimizing service, and driving innovation in urban development. My name is Renata. I'm an architect and I'm a program owner in institutional relations at Ziggurat. If you're not new here in Ziggurat, I will give a quick introduction of ourselves. We are an online educational institution with over 20 years of experience in new learning. We offer master's and postgraduate programs in architecture, engineering, and tech management, helping professionals around the world advance in their careers. We are incredibly proud of our diverse and dynamic community with more than 20,000 students from over 120 countries. And before we begin, I'd like to invite you to participate with us in the chat. So please tell us where are you joining us from today, which country are you connected from, and let's keep the energy high and make this an interactive section. And today's session is deeply connected to our flagship programs, the Masters in Global Smart City Management. This program equips professionals to develop and manage sustainable and inclusive urban initiatives based on the best international standards. To tell more about the master, I will invite my colleague, Elena Senatorova. She's an international career development and admissions consultant here in Ziggurat. Elena, welcome.
Hi, everyone. Welcome to this special masterclass, and thank you for joining us today. I'm here to introduce you to the key topics of the master program in Global Smart City Management. In this master degree, you will learn how to design, how to manage smart cities that are more sustainable, more efficient, and better connected to the people who live in them. Let me briefly walk you through the structure of the program. In the first block, you will learn how smart cities are planned and financed, and how citizens' needs and data play a central role and decision-making. You will also explore where the business opportunities are and how to manage city projects from the strategic point of view. In the second block, you will study the technologies that make everything work, like connectivity, data security, digital platforms, and the newest tools that are changing the way cities function. We will talk about emerging technologies and how they can improve urban life. Third block focuses on how to make cities greener, stronger, and better prepared for change. You will explore sustainable mobility, circular economy, urban planning, and how to deal with an external pressure like climate change or population growth. This program, you will work on a real project where you can apply what you have learned to solve challenges related to smart cities. That will be your final master project, and this is basically your opportunity to shine and show your vision for the future. The program starts in November 2025, dual master degree upon successful completion of the program. Okay, let's go to the next slide, Renata. Now, why choose Ziggurat? Some of you may be still wondering. Well, first of all, our master is top ranked in the smart cities. We use an interdisciplinary approach, meaning that you will learn from many fields and professional experiences. The learning is hands-on and practical with the real case studies. And you will be part of the global community. If you can change the slide, Renata. So global community, learning alongside people from very different countries, professionals involved in a smart city initiative, so it will be very interesting. And our program connects you with an international experts because our professors, they're all these practitioners. This program also prepares you for the new career opportunities around the world. Normally, our graduates work with city councils, consultant firms, tech companies, and international organizations. So this program opens the door to global career opportunities. If you can change the slide, Renata. So basically, this program is not just about learning, it's about building your career. And upon successful completion of the program, you can work as a smart city project manager, urban innovation consultant, sustainability and resilience planner, technology advisor for cities or public sector or NGO smart city expert. At Ziggurat, we don't just teach smart cities, we train leaders who are ready to transform tomorrow. Thank you. That's all. Let's continue with the masterclass, and I hope you enjoyed the session.
Thank you, Elena. Thank you for your information, your time. For those who couldn't scan the QR code, I'll drop the link in the chat so you can get in touch with one of our advisors. Now, it's my pleasure to introduce our guest speaker, Hossam El Shoukry. Hossam is head of Smart Cities Engineering at Honeywell, a Smart City Solution Expert and Ziggurat alumni. With a unique blend of systems engineering, urban tech, and platform integration, Hossam has led major smart cities and IoT projects across MENA, acting as master systems integrator for cloud-native infrastructure and future-ready ecosystems. He's driven high-impact urban transformations by aligning strategy with execution, ensuring performance and interoperability across complex tech environments. I welcome you, Hossam, and for you that is hearing us, please leave your questions in the chat that Hossam will answer you in the end. Welcome, Hossam.
Thank you very much, Renata. Thank you very much for the introduction. It's really a pleasure to be here, being an old Ziggurat alumni. It's always a pleasure and to participate in such educational initiatives driven by Ziggurat to spread the knowledge of technology in different domains, whether it's smart cities, whether BIM for construction, whatever it is. So it's always a pleasure to be here. I'm going to start our master class with regard to the generative AI opportunities within the smart cities. Just let me know when the screen pops up, please. Very good. We're going to be talking about generative AI, the buzzword that have been spreading around the world since the last 3 or 4 years, transforming how we were performing in our daily life. And we will see how this is impacting the way that smart cities being operated and how we could benefit from the privileges that's provided by the generative AI within the smart cities domain. Before we go deeply, I will talk about the smart cities. I would like just to start with the basics and fundamentals. I would like first to start with what's in essence is generative AI. Generative AI refers to a kind of artificial intelligence system that can create new content rather than simply analyzing or classifying existing data. And this new content is going to be based on analyzing and sensing the data sets that's being fed to the artificial intelligence algorithm here. When we're talking about data here, we can mention the key inputs and outputs of generative AI models. We're talking about text, whether it's articles, stories, policies, reports. We are talking about image, like visualization, designs, art. Also, generative AI can work and generate software codes, algorithm application, and simulations as well can be generated by generative AI, similar to urban scenarios and traffic patterns. There is a big difference that generative AI created compared with the traditional artificial intelligence models. And for example, we usually give in the industry this simple analogy so that we can try to make the idea much clearer to the audience. All the traditional AI models are classifying or predicting data based on the input data only. So it's a matter of selection, whether this, for example, this image or whether this ticket refers to a cat or a dog. However, generative AI is not just predicting or following a certain pattern so that it can generate data. It can create a kind of originally new content that was never existed before, based on classifying the patterns that have been drawn from the data set it's being trained into. Some people might think that the generative AI was a kind of sudden burst in technology and something that came up without any, I would say, background research or something. This is totally a kind of incorrect argument. Generative AI was a kind of an outcome of years of research in the artificial intelligence with different domains that concluded with generative AI, which was easier for the public and more usable for the public. Generative AI is a kind of part of the artificial intelligence domain, which mainly we describe any technique that may enable computers to mimic the human behavior here. From this artificial intelligence part, there is a subset of AI techniques which use statistical methods to enable machines to improve with experience, or what we call it learning. These machine learning techniques also have a subset called deep learning, which uses techniques associated with multi-layer neural network, which enables the artificial intelligence to handle different data stream, different types of information in the same time. And this is why even it's described as a deep learning. Out of this deep learning techniques, we have the generative AI, which is a subset of the deep learning that can generate new original contents, same like what I described, like images, text, or video, that it resembles the data that we trained on. So the generative AI was only coming up to the public because it was enabled for public use with a simple application like ChatGPT or something. However, this is something that did not pop up all of a sudden. It was a result of years of research that has been kept into the labs and, or I would say, for scientific uses. The only thing that has allowed generative AI to come to the public is how easy the application has been made out of the generative AI technologies. If we're following actually the real trace of the generative AI history, we find that we can define 2014 as a starting point for the GANs. And this is actually refers to the deep learning techniques that was resulting in the generative AI techniques that we are following right now. This was by 2014. And then at 2017, this were the game changers with regard to the large language model came up, which is the transformer architecture. There is actually, what has created all the buzz in 2017 is a kind of research paper that was titled as Attendance is All We Need. And this is what laid the ground for the transformer architecture, which resulted in the large language model that we are using in a daily basis within models like the ChatGPT or the Llama or Cloud Gemini. In 2020, GPT-3, which was the first model that was enjoying text generation capabilities, has been come to the public. And this was the early, I would say, launch of a generative AI application that can be used by public and lay persons. And then this has been evaluated into another models like bringing image generation to the mainstream. For those early adopters who has been using the generative AI application since long, they would remember that the first model that was come to practice were not able to handle and process images. This evolution has happened 1 or 2 years afterwards when the new models that are able to process images has come out. And then we're ended up with the multimodal AI systems that are combining text, images, and other modalities like videos and everything. The key point that you can get here out of this slide is that the evolution of the generative AI techniques in the last 4 or 5 years is done in a kind of exponential way compared with what's happening in the last decade or something. This is a kind of field where everyone is focused into, where all research labs are trying to come to make the best use of this. Smart cities are not exception on that. And this is why we thought that we would be delivering this masterclass to see how we can make the most benefit out of the generative AI. To give a little bit of background, or what we call it under the hood details about how generative AI works, generative AI mainly would have a kind of 5 phases like what we see right now. The first one is the data pre-processing. Let's remember through the masterclass that generative AI, if we look into generative AI as a vehicle, Data would be the fuel of this vehicle. Generative AI is used to receive data, to handle data, to train or pre-train the data that it receives so that it can identify the patterns within these data so that it can come up with outcomes and insight based on these data sets. Worth mentioning that data preprocess under this stage of data preprocessing lies a strong or robust infrastructure for data platforms that receives or used for ingestion of the data and processing it and streamlining it so that it can be ready to be trained by the AI model. And this is actually what is called in the smart cities domain the smart cities platform, where it's used to connect to the city physical sensor or systems to receive the real-time data out of this sensing element. After the data preprocessing, this is where the AI model starts to be trained, and then the patterns are being identified. I'm going to give a little bit of analogy here to give you a hint how this training and how identifying patterns work so that you can get to the idea clearer here. If you have a kind of a little kid like 1 or 2 years ago, 2 years old, and you're trying to teach him how to talk, you first try to point out to objects, whether it's an apple, whether it's a chair or something, and then you try to tell him what this word means. And then after that, you can try to combine this word in a context with some actions. Like, for example, if you're referring to the apple, you can use the verb, I would eat it, so that you can help him have a sentence like eating an apple. This is actually what the algorithms do with regard to the generative AI or large language model. It draws a kind of mathematical correlation between words in certain contexts. It's more of a statistical mathematical models to have a kind of context trained and then generates another context based on this correlation. All of this comes under probabilistic data so that you can be able to kind of enhance the probabilities of the context that's being generated from that set that's being trained on. And then eventually the probability of generating responses and answers for the queries that you make to the large language model enhances by time, since the probability of success of those correlation created increases by the time and by the feedback from the trainer. So in a way, if we are comparing the human thinking and the generative AI, we can see that generative AI uses statistical correlation in large data set. It's all about mathematical and statistical model, while human thinking builds the internal models on more than that. Human thinking goes into experience, goes into emotion and context. This analogy came up at some points when some people were trying to address some risks out of the AI and how it could replace human thinking. However, practitioners and the people who understand how generative AI works, truly understand that still, at least so far for now, there's still some level that generative AI is not able to do. I wouldn't say that this would persist for long. For people who is following the AI industry knows that there is a lot of talk nowadays about general artificial intelligence, where it can use some modeling, I would say, for emotion and being very close to comprehending the human thinking here. The fact that generative AI uses statistical correlation in data sets, it made some people argue that it's not that the magic that everyone is waiting for. This is actually what made Sam Altman Sam Altman, the famous CEO for OpenAI company, the famous AI guru, come up with the statement that it's not that simple. A language model, it's not just being programmed to predict the next word from the mathematical models. It's more than that. Correlations and the word's meaning that's being generated out of finding the relation between them and the context can generate a lot of novel ideas, a lot of new content that the human mind cannot for the time being generate due to some other capabilities. Let's remember that the fact that distinguishes computers on humans sometimes is the capacity to handle information and the capacity to correlate between different inputs all together in the same time, which sometimes makes having this correlation by the artificial intelligence technology is an advantage that goes over the human thinking here. Considering or looking into what we have just mentioned, we can come up with the objectives and the capabilities of the generative AI. If we're talking about multiple streams of data with different types, with different contents like text, image, if all of these are being pre-trained for the model and used to come up with a new or new generated content. Definitely, prediction might be one of the objectives and capabilities of generative AI, since the outcomes associated with pre-training historical data and complex pattern and using advanced generative AI algorithm to identify those patterns and come up with forecasts. This is one of the main advantages of generative AI over other techniques. We're also talking about how creative would be the way generative AI is digests information and starts to understand the correlation between the data sets and how they could generate novel ideas and design that may not have been considered by human planners. So creativity is one thing we're going to be looking for when we are trying to see the value proposition with generative AI in our cities. Content generation as well, whether it's a creation of texts, whether it's transforming some images from one format to another so that it can help the situational awareness or decision making. Coming up with a new media tools for communication and visualization is something that we can get from generative AI as well. And of course, the main advantage of having generative AI is that the ability of combining diverse data sources to generate comprehensive insights. This is something definitely cannot be done using the traditional ways or using the human factor here. It can be done, of course, but with a limited capabilities, which when we are talking about smart city context, which receives different data streams from different domain, whether from traffic, whether from weather and the environment, whether from emergencies. This is definitely something that cannot be done with traditional airway. And this is where generative AI overlaps with the smart cities objectives so that eventually you can be able to manage the complex real world scenarios associated with that. So from what we have just demonstrated, there are multiple things or multiple objectives that you can have for your city from generative AI. Considering the urban complexities that currently cities are being faces, it wouldn't be logic to think that cities can be run with the old and traditional ways where data are being in silos and where analysis or analytics uses the traditional methods here. When we're talking about a modern city nowadays, we're talking about a dynamic city with billions or trillions of transactions happens at each second or each point of time. This is we're having different domains like infrastructure, like services, like resources, all happening in real time. All of them are generating data. And in order to be able to manage cities' interaction efficiently, having a kind of technology or a technique that would be able to digest all these data, come up with insights, and even generates a kind of outcome based on this data is no longer a nice to have thing. It's a must-to-have thing if we're really looking for running our cities in a kind of modern and efficient way. In the same time, citizens' expectation currently is no longer same like before. With all of the technology hype that we are having around us, definitely citizens are looking for a new urban experience and the better urban services in terms of the faster response and in terms of the personalized services as well, that can handle the changing conditions and individual needs. Nothing is tailored for all, since currently cities are more dynamic than before, and there is nothing like a fixed conditions that cities has to handle. Conditions, whether it's from atmosphere, whether from weather, whether from traffic, are changing every now and then due to different variables happening each and every day. This is why the generative AI is considered a kind of an era beyond automation. Automation, in essence, depends on fixed variables that can trigger an action or even trigger some outputs based on a fixed variable like time or something. Right now, there is nothing fixed in city dynamics. Cities are changing each and every second. And this is why there is a need for generative AI to serve the decision maker to enhance the urban intelligence and to be able to provide the efficient services as expected from citizen and from city municipalities as well. This is why the potential for the generative AI is very promising. How would it be that? This is what we will go into the next slide. But before we go into the smart city use cases, would like just to give a word about what exactly is expected here from the AI in terms of the smart cities. If we look into this hierarchy, we can split, I would say, the smart city infrastructure into the first or the foundation would be the sensors part, which we might call it perceptual. This is the part that would be transferring the data about a system or city behavior or performance from different aspects, whether from traffic, whether from, I would say, hospitals, whether from atmosphere, whether from environment. This is where the data is being ingested into the technology or the platform itself. And then we're going to be using the first layers for doing a kind of reasoning with regard to this data, so that it can be classified, so that it can be matched with the urban conditions of the current city that's being operating into. And then comes the last layer, what we are currently interested into, which is the generative AI. How to deliver these or to turn or transform this insight into a kind of forecast that that can be used into the planning in different areas. The key point that you can get from this slide is that generative AI is turning cities from being reactive to a proactive. Right now, the data being ingested and data being processed will not only be used for doing an imminent action. No, it will be used also to enhance the responses, to enhance the plans, to understand the future insights about the city that cannot be run using the usual way. So your city will be more proactive to, I would say, natural catastrophes, natural disaster, will be more into a planning mode or proactive mode for the emergencies. And this is all due to the data sets that's being trained and ingested from your city through generative AI techniques and algorithms. The key point behind the generative AI is what we call the foundation model here. The foundation model is a kind of class of what we call deep neural networks. And without getting much into a technical part, this deep neural network handles data sets as a kind of mathematical equations, where each sort of mathematical equation is called a neuron. And this neuron can receive data and then do some kind of algorithm to correlate the data together. These foundation models creates a base of knowledge that can be applied to many different tasks. If we're giving an example with a large language model that we are using with the current AI application, we can see, of course, the famous GPT model that's used in ChatGPT, which is an abbreviation for Generative Pre-trained Transformer Model. This model is pre-trained on, I would say, billions of terabytes of data sets that's coming from the web, from the internet, from library data sets, so that it can drive the correlation between words and contexts and come up with the responses that you see when you query something over the large language model user or something. If we are applying the same set of principle here, we'll find that this does not apply only in some kind of search and query model like ChatGPT. If you are providing the model with a data set associated with the traffic, you can provide a traffic insights. If you're providing a data set associated with environment and weather, you can also drive insight the same way. And when we are talking about data set here, we're talking about text, we're talking about images, and we're talking about video. And if we're trying to make a differentiation here between the city context, the image that you're uploading to ChatGPT would be in a city scale, would be, let's say, a satellite image. The data that you are putting as a question here might be a kind of real-time data associated with the temperature in a certain area. So this data can be used to generate insight according to the domain where this data collecting, using more or less the same model to be accurately precise. Yani some of them might not use the same model, but there are multiple similarity. What matters is that it can be driving the insights from the data set it's being trained into. To give you more idea about how this would work in different domains, we can give an example of computer vision and images and video foundation model. This kind of model is used to process data, whether this is a kind of images or a video foundation model, and it can do multiple tasks associated with that. They can do image classification, they can do object detection and image captioning. Image captioning, for example, you can ask a question about an image itself and receive an answer in a way mimicking the human response here. We have also the visual question answering, which works in the same way. For video foundation models, if you're training the video foundation model with different videos and stream, you can also have a kind of action recognition so that you can receive a kind of reporting about the actions being detected through the video stream. We also have the object tracking, where you can track object in a video stream or something, and similar to that, video captioning, which uses natural language so that it can describe a certain video. We also have a video detection and a spatial temporal segmentation, where you can define a certain segments within the video streaming itself based on a kind of prompt or a kind of a natural language query or something like this. This is all kind of tasks that can be implemented by the computer vision images and video foundation models. This is not something futuristic. For the meantime, we have multiple models that can work in the same way. And for images, if you research, you will find that there is Dino V2 for the Meta, implemented by Meta company, and there is an Open AI clip, Microsoft Cosmos, DeepMind, Magic Lens. For videos also, you can find VideoBird, Violet, and Huawei Video Mai, and WebVid 2M. There is also some kind of, I would say, a video and image foundation model, but for geospatial purposes. And this is actually, we're going to touch on that in a deeper level within the next slide, because it's very useful within recognizing geospatial data from satellite image. Several video and computer vision and video foundation models can be used, and they have different kind of applications within the smart cities. All are revolving about analyzing and kind of classifying the data being received from the images and videos detected by different city systems, so that it can provide predictive and analytical capabilities in a kind of prompt time and in an efficient approach as well. Some of the, I would say, correlated activities for those computer vision and images and video foundation is the emergency response action. The videos that are being detected from the cameras can easily identify whether there are casualties within a certain incident or something, so that the decision maker can direct the right resources to save the situation and mitigate any action here. There is also an understanding of the location using satellite and airplane imaging by kind of giving an analysis to those images, regardless of whether those satellite images are related to the incident itself or not. Detection of natural disaster by following the patterns and the changes within the land and the water areas accompanied within a certain natural phenomena. Planning of infrastructure work, computer models, vision for vehicles, smart traffic management, support city authorities and citizens. All of this uses the same principle and works in a context related to the smart cities here. Similar to that is the traffic and transportation foundation models. And the beauty about the traffic and transportation foundation model is that usually since a long time, the traffic and transportation foundation models were only logged into labs and by big company. Currently, there are a variety of types and models that could model traffic, and it can have an open source model that's make it available to smaller companies, startups, and the municipal organization. So traffic modeling and transportation modeling is no longer used by big corporates only. No, currently it can be enabled by a smaller scale organization for use and for application use cases. The applications here is multiple and diverse. We have the traffic monitoring and prediction. We have the smart parking management, depends on the, I would say, the data available from the parking slot using parking sensor. We have also the driver assistant transportation planning. This is very important following the, I would say, transportation patterns, and the high peak times and the high peak locations can help for better planning for transportation and even understanding the timely pattern that associate these peaks along with different events and situation. Disaster management and emergency response is always on the go. Since in a crisis or in a disaster, 1 second can make a difference. 1 second of proper planning and 1 second of earlier action can make a big difference. We also have the text analysis for insights from social media about urban traffic, and of course the smart and fleet management, which segments different fleet patterns so that it can derive analyze based on that, specialized and segmented as well, like grocery and video food delivery and public transport. And there are multiple For the time being, there are multiple foundation models associated with the traffic and transportation. We have the Transworld by Castlab. We have the Traffic GPT, and I'm just gonna stop a little bit here. Product-wise, there is nothing called a traffic, or there is no product labeled as a Traffic GPT. However, this is a widely known or widely used naming for the traffic foundational models that's associated by the large language model. So that, for example, you can use a human-based queries and text, same like what we're using in ChatGPT, to receive analysis and to answer questions associated with traffic patterns or traffic analysis. So it's a more of a kind of providing large language model associated with the traffic foundation model, so that you can easily receive insights and easily receive outcomes from the traffic foundation model for emergencies and for, I would say, use cases associated. We also have open source models for the traffic transportation and foundation, like DCRNN, STGCN, ASTGCN, and SGAN. All of this, they have their codes deployed into multiple areas within the internet, so that it can be used in a different application as an open source model. Each one of them definitely have a kind of strength and a point of improvements. So selection of which model to use depends on your use case and application related. We also have the environmental weather and the climate foundation models, which is used for multiple things associated with weather and air quality and the natural disaster, like forecasting, nowcasting, data assimilation, and even climate text analysis and weather pattern understanding, and extreme weather condition like floods and like natural disasters, I would say. And there are multiple here mentioned in the screen as well, so that they can be used. Some of them are for commercial purposes, and some others are open source that can be used in different application. And then comes the natural language processing and the automatic speech recognition models. NLP models is, or let's say the LLM is one part of the NLP models, when we have seen already how they react into generating responses in a human-based or mimicking human based on queries and questions in natural language. And also there is the automatic speech recognition models, which mainly works so that it can transcribe speech, understand how people talk, even if they speak fast or unclearly. They can be used in order, definitely they are trained over a large number of hours on multilingual and multitask supervised data collecting in the web. They can use to understand the audio voice for humans and generate responses and associated feedback based on that. And we will touch on that in one of the famous use cases, what we call it a digital human here. So if we kind of try to combine the key model types for smart cities, we have seen that we have touched into the vision models, where it's kind of meant to process images and videos so that it can generate outcomes and detect issues and the changes. We have the multimodal models that can combine text, images, and sometimes even audio understanding. Again, this for situational awareness, where you're trying to combine different sources of data so that you can come into or have better insight in a certain situation, incident, or event. We have also the simulation models, where it's used to understand the patterns and try to come up with a predictive models for certain scenarios and policies or emergency situation. And when you see the outcome of these simulation models, you can build your plans accordingly without being reactive or without having some kind of unexpected performance or behavior, whether from external factors like nature, like infrastructure, or from internal factors like your emergency response team. And ending with the natural language processing and large language models, which is mainly can understand and generate human language, whether for documentation, communication, and planning. This is from a functional perspective. We will find that these different models can be, I would say, merged together or fused together so that they can provide use cases and application for a certain domain, city domain, whether it's environment, whether it's traffic, whether it's citizen engagement. However, the models that we are working with are revolving around those four models in summary. Okay, type. Here's the fun part, I would say. If we're looking into the use cases associated with those models, and in the past couple of, in the past section of slide, we have identified the generative language, the generative AI. We have given a hint, how does it work with, I would say, digesting the data sets fed to the model itself and trying to draw correlation. And by drawing this correlation, you can come up with outcomes and insights that was not existing before, so that eventually you can be able to drive more efficient operation, planning, response, and turning your city from being reactive to a proactive. There are different domains where you can use the generative AI to help you enhance the response and enhance the performance here. We have the urban planning, we have the citizen services, we have the emergency response, we have the environment, we have the energy. If we're going to start with one of the most important part, which is the incident and emergency management, we'll find that the generative AI can help us with doing comprehensive action plans for different emergency scenarios. We also might have an optimal evacuation routes based on the population density, and even draft emergency communication dynamically and tailored message for different platforms. This might come with the fusion, as we discussed, with different model. For example, getting the data from the city surveillance through the Vision Foundation model can analyze CCTV feeds for hazard detection, and even this can be combined with satellite feeds as well, so that eventually you can find the different patterns that's already happening within different emergency scenarios, see the weakness point, see what can be improved, and then try to come up with a kind of response plan that adapt, I would say, the non-conformities that happened during the emergency situation. The same applies over the evacuation routes, since not all the evacuation route might work in a certain area or in a certain path for emergency, depending on the population density, traffic conditions, emergency type, and the use of generative AI to analyze the different data streams, and even come up with a kind of report about it. This would help the decision maker to come with the optimal evacuation routes. And even during some incident or accidents, the incident management can be helped by getting a direct information from CCTV video feeds and analysis, similar to what we receive during a kind of human operation. From this perspective, actually, we're not talking about futuristic things here. When we're talking about analyzing video streams and talking to it like a human being, we're not talking about something futuristic. Such models are already enabled for commercial use by different companies. Right now, we're going to see an example of how these models behaves and performs within the use case associated here. From what we can see here is a kind of video stream that's being analyzed by AI techniques. It shows a kind of intersection for a certain area. And then I've added a prompt to provide a kind of report about traffic-related events. From what you see here in the screen, that there is a traffic report that classifies the events by time and by the vehicle IDs that has been passing through the videos. And here you have got a report, a detailed report that you might get from operator, not from a machine or something. You can even ask this report different question, same way like you're asking ChatGPT or something. If you're looking into that from a perspective of emergency situation, imagine that you can get, in case of incident or emergency event, imagine that you can ask the video feed how many incidents or casualties in the situation, what exactly their status, or whether they need medical care or not. You're talking about a huge saving in time, better assessment of the situation, so that eventually you can come up with the right resources and the right, I would say, emergency support for those people. Again, this is not something futuristic. This is something happening nowadays, and these models are available. You might be the next one to implement this to your city so that you can enjoy the analysis and the top, I would say, capabilities of the generative AI to be used in analyzing different video feeds and come up with associated insights. We have also the personalized citizen engagement. A large language model can be used or can be trained over data sets associated with, I would say, policies and communication associated with the city, different, I would say, services that's required by the citizen. And this can be providing a higher level of service and higher level of information and a better citizen experience to the city citizen as well. We're not talking here also about something futuristic. You will see now James, our new city assistant. One second. Okay, for some reason, this digital human is not functioning, or the demo of the digital human is not functioning. However, the idea behind this is that you're going to be able to talk to an avatar that resembles a human being. And from that, you can ask question similar way that you're asking ChatGPT. And in the same time, you receive an answers with a natural and the human language. Imagine that you're having a customer service employee or a customer service professional having all the data sets and having all the city information in his mind, and he's available 24/7. I'm gonna jump quickly to the other parts considering the time limitations. We also have the flows and surface water detection. And this is, by the way, very important and very relevant because actually this is using Prithivya geospatial foundational model. Such a model is using, it's an open source foundation model, by the way, and this has been done by a German organization and IBM and the NASA, and it's used to analyze geospatial data and transforming raw satellite data into pictures of Earth changing landscape. In fact, during the unfortunate Valencia's latest catastrophic flash floods, the model has been used to map the extensive flows the extent flows that came out to the area so that the decision maker can understand the space and the area where floods have covered the city and accordingly direct all the emergency support using these models. Such a training for this model depends on the flood data and how the different factors like the sea level, like the land area, like the temperature, how these levels are associated with the flood event itself. It can definitely be used to predict certain floods that may happen during similar periods of the year so that the emergency response can be more prepared and more proactive and have less casualties and lesser, I would say, damages out of these floods. Also, we have similar models to support within the urban planning and simulation, since these can depend on the vision language model and the fusion models as well, to generate a city design suggestion from satellite images and map, considering different data sets that are being combined together, like combining traffic data with the green spaces and with the patterns of the traffic running around cities and around areas of mobility. In fact, there is a famous model that's called SAR2 height. This is a framework that allows to generate georeferenced data from a satellite image and converting these satellite images into a 3D models from a single, I would say, satellite or rather image, rather than taking a lot of drones images and rather than taking a lot of information that takes time and effort. This model can easily generate these 3D maps from the single radar images, and this is definitely highly useful for urban planning, for disaster planning and response as well. There is also a model called GLOFAS. It's working in a similar matter as Prevenith, so that it can also predict extreme floods and engage watersheds. We also have the mobility and the traffic models and other use cases associated with that. If we come up with kind of actual use or actual implementations for this, foundation models and the use of AI technologies, will come up to a few cities that already has started implementing generative AIs in their cities. I think I stopped sharing. I'm going to be sharing right now. You see my screen right now? Okay, perfect. The early adopters of generative AI was mainly those cities. We have Seoul, who has implemented an AI-generated service system via a chatbot, which can handle thousands of inquiries daily without complaining and without feeling pressured or something. This can also come across different language. This is reducing wait times and improving accessibility as well. Personally, I have a kind of opinion with regard to having generated AI citizen services, because in the earlier slide, we mentioned that generative AI, as of now or so far, is missing the emotional part. And you know, when we are dealing with a citizen in a certain emergency or something, definitely you would be in need an emotion alongside the information as well, not only the information part. So I have a kind of point of view that this might not be applied into emergency services, since humans and emotions that used to be calming people in an emergency or a disaster definitely would be most important than providing them with the information. But again, this is a personal opinion, and who knows what would happen next. Also, we have Amsterdam, which uses urban planning simulation, similar to the model that we have seen that analyzes satellite and radar data and associated with different traffic patterns and traffic condition. They have used these generative tools to model the impact of tourism and housing policies and transportation changes on its historical canal districts. So these historical canal districts were always having a kind of traffic jam problem and having different urban issues that occurred within the city. And they have been using the simulation models provided or enabled by the generative AI so that they can try to come up with a better planning for the area and the better, I would say, policies to avoid this issue. Last of those city use cases, Singapore, which employed already the AI for flood protection and for the automated alert content. We have already touched on the weather and environment monitoring flood protection model that has been used in Valencia. And by the way, the same model has been used in Brazil as well, and other third country, which allows for predicting the floods and which also allow or enables automated alert content generation and precise warning to specific neighborhoods based on real-time weather data. Those were the three cities that were early adopter for generative AI's technologies. Your city might be the next, as long as you understand how important are these technologies to your city and how needed it is for managing the complex dynamics and complex transaction that's happening in the city within each and every minute or even second that we are having right here. This does not come out of challenge, of course. Definitely when we're saying that we're using data, we have some challenge that technology even is working to resolve for the time being. Some of them are the bias in the AI generated, since we are already feeding the data from some content that might be subject to human bias. Definitely the AI system can cascade the same bias in the outputs that's being generated here. So whatever decision maker or operator might be aware of this part. Governance frameworks, we have just been mentioning that governance frameworks can be fed into the data sets and the generative model so that it come up with insight. However, let's agree that governance frameworks sometimes are not as clear as being digested within the AI models itself, which might create a confusion and some transparency and accountability issues. And the data privacy and security remains always in the background with regard to the generative AI system, since a vast amount of city data are being, I would say, processed and used to generate outcomes. So there might be a question about the data associated with citizen privacy and how to prevent using them as how to prevent misuse of them and being subject to be a security vulnerability as well, whether they are personal information or some kind of data associated with their personalities. In conclusion, I would say we have seen how advanced and what are the valuable benefits of generative AI in helping cities to manage their complex interaction and complex dynamic. I don't see that it's no longer a nice to have thing or something that we can brag about for show off in terms of cities. Cities are becoming increasingly dynamic. Cities are becoming subject to a lot of, I would say, issues or turmoils that cannot be predicted or cannot be correlated using the traditional or conventional methods. Only generative AI can be used to drive this insight and help the proactive planning for cities and the proactive, I would say, insights associated with how cities would perform. And this does not mean that human factor will be replaced or removed. No, actually, the human AI partnership is what drives the best outcome here. Having the tools to provide or to enhance the processing of data with the human capability and creativity for decision making and problem solving, this is what it needs to resolve the complex urban problems and the complex issues that encounter the city municipalities and the city citizen amid all the dynamics that's happening within our modern era for the time being. Thank you very much. And please, if you have any question and answer, I hope, Renata, I met the time. I have a lot to say, but I'm respecting here. I'm respecting here the time period that we have agreed together.
That was very good, Hassan. Hossam, thank you for sharing your knowledge and insight with us today. It was a very inspiration presentation, and I think we don't have no questions from our participants. So I'd like to ask you to leave a final message for us, Hossam.
Absolutely. Thank you very much. Thank you very much, Renata. Currently, having new technologies within cities needs some kind of advocates or champions for these technologies to kind of spread and extend the knowledge for it. These advocates and champions might be you. So don't hesitate to get the knowledge. Don't hesitate to ask questions. Don't hesitate to understand what this technology is so that you can put it into the benefit of your people and for your city. So please keep it up. Technology is evolving. However, as long as we have champions like you, definitely will bring the best outcome to our cities and people here.
Thank you, Hossam, for your final thoughts. So I think it's time to wrap up today's masterclass. Thank you again, Hossam. It was a pleasure to be here with you today. And thank you, everyone who stayed with us until the end. So until next time, see you. Bye-bye. Bye, Hossam. Bye, everyone.